Hello everyone. So for today's video, we're going to go ahead and introduce this idea of systems of linear equations, and then we're going to talk about two types of methods used to solve these systems, that being the method of substitution and the method of elimination. Okay? So why don't we go ahead and get right into it. Okay, so before we get into this discussion of systems, I first want to go ahead and touch upon this idea right here and ask the question, what is a solution to, say, something like 2x plus y equals 5? Let's go ahead and discuss that for a moment. So, this is a linear equation. This is a linear equation of two variables, x and y. We know that graphically, when I graph this equation, it makes a line, right? A straight line. And that line is a collection of points, x comma y. And that all points on that line are solutions to the equation. So since that line will stretch on to negative and positive infinity in both directions forever, there are infinitely many solutions to this equation, right? There are infinitely many points that satisfy this. For example, 2, 1. The point 2, 1 is a solution to this equation. The point 0, 5 is a solution to this equation. The points 5 over 2, 0. These are all solutions to the equation. There's going to be infinitely many of them. Alright? Now, moving on from that equation, let's also talk about how about 3x minus 2y equals 4. What is a solution? What are solutions to this equation? Again, this is a line. It's going to have infinitely many solutions. Some of them are 2, 1. There's also 0, negative 2. And another one is 4 over 3, 0. Again, all these points are solutions to this equation. So when we're looking at these individual equations of lines, or when we're looking at these individual solutions, we can understand that graphically they're going to have infinitely many solutions. Alright? So these single equations have infinitely many solutions. Alright? Now I want to keep that in mind as we now move into the discussion of systems. And we're going to see how this idea of that we're guaranteed infinitely many solutions when we're looking at these individual equations is going to change with this new idea of systems of equations. So let's go ahead and talk about that now. Okay, so let's go ahead and give a definition to what we mean by a system of equations. So for us, a system of equations is a group, and that group is another word for system, of equations in which solutions to the system are ordered pairs, in other words, points, that satisfy, and here's the key, that satisfy all equations in the system. Okay? So going back to what I talked about earlier, if we consider this following example, the system of equations 2x plus y equals 5, 3x minus 2y equals 4. So just I guess to get the notation out of the way real quick, this big bracket, how this big bracket, or like big curly bracket, is encompassing both equations. This is our notation for systems. If you see something like this, that is indicating these equations grouped together are viewed as a system. So curly, big curly brackets means system. So, going back to this definition and viewing this example right here, when I want to talk about the solutions to this system, right, I'm not talking about the individual equations. We know the solutions to this individual equation. We just talked about some of them. Same thing for this one right here. Now, on their own, each of these equations have infinitely many solutions. But when asking for the solution of the system, we need to find a solution that satisfies both of these simultaneously. So if we have a solution that just satisfies the first equation, but doesn't satisfy the bottom equation, then it is not a solution to the system. So solutions have to satisfy all equations in the system, and that's pretty much going to be the biggest difference from what we've been talking about before with single equations. The big difference between single equations and systems of equations is in regards to their solutions. For systems of equations, solutions need to satisfy all equations in the system. That's the big core difference, okay? So now that we've introduced this idea of systems and have an idea for what it means to be a solution to that system, let's now get into our techniques for solving them. So first we're going to start with this method of substitution and talk about how that solves systems of equations. Okay, so here's our first method for the day, that being the method of substitution. All right? Here's the general outline of the method. It comes out to be roughly a 5-step process. So step number 1 for method of substitution is, in your system, you're going to take one of your equations. So, for example, we'll take the equation 2x plus y equals 5. All right? And step 1 says, take that equation and solve for one of the variables. Right? Isolate one of the variables. So for our 2x plus y equals 5, we would do something like, if we solve for y, we would get y equals 5 minus 2x. We have taken one of our equations and we have solved for one of the variables in the equations. That's what step 1 tells you to do. Step 2, and the most important step in this process, and why this process gets its name, is that we are going to substitute that variable we just solved for, so y equals 5 minus 2x. We're going to take that and we're going to substitute it into our remaining equation, right? So that's all step 2 is just take whatever variable you solve for, plug that into the equation you haven't touched yet. And why this is so important, why this is so useful, is because in step 3, what you should end up with is you should end up with one equation with one unknown, right? We have gone back, we've circled all the way back to the beginning of this class, and we're going to have something that we've been doing since day 1 we know how to tackle. That being one equation with one unknown. So in that step 3, we solve for that remaining variable. So for us it would have been x. We just solve for that x value. And just like that, we know one of our values. We know what the x variable has to equal, okay? And since we know what the x variable has to equal, we can use this to find y. And that's what step 4 is this idea of back substitution. Okay, so this is a new type of like mini technique, I guess you can say. I guess we haven't really encountered it before. We'll see it in our example, but all back substitute means is take that variable you just solved for, x equals some number value, plug it into one of your original equations, solve for that y value. Find what your missing variable is. That's what step 4 is. And then lastly, step 5, the universal step, the step that is true for all methods throughout time, throughout all classes, throughout all educational levels. We check our answer because we probably made a mistake. So let's make sure we find where that mistake is by checking our answer, all right? So this is the 5-step process. Pretty straightforward. You'll see when we do an example, which we'll go ahead and do right now. Actually, before we start the example, forgot to give you guys a moment to go ahead and pause the video and get this all copied down. Okay, now let's go ahead and start our example. Okay, so for our first example, we'll go ahead and solve this system with substitution, and this being that system we introduced at the start of the lecture, 2x plus y equals 5, and 3x minus 2y equals 4. So let's solve this system of equations. So, our substitution technique, the very first step said, pick an equation, solve for one of the variables in that equation. So I'm going to pick that top, so this will be my step 1 in my substitution technique. I'm going to take that top equation, 2x plus y equals 5, okay, and let's solve for y. So I'm going to solve for y. Let's go ahead and do that. So, I kind of already said it out loud in the previous step, but solving for y, very simple. Just want to isolate this y variable, so I'm going to move that 2x over. So I'm going to get y equals 5 minus 2x. Now I guess I want to take a moment to pause and talk about this first step. So something important to note is I didn't need to pick this equation, alright? I could have picked this equation if I wanted to and solved for one of the variables here. Also, I didn't need to pick to solve for y. I could have simply solved for x. That would have been totally fine. To walk through why I chose this one, well, I chose to solve for this equation. I chose to solve this equation for the y variable simply because if you look, solving for the first equation, y variable, is the only one that doesn't involve a division, right? If I had chosen this equation and solved for x, I would have needed to divide by 2. Similarly, if I had chosen this equation and solved for either variable, there would have had been a division I needed to do. So I simply decided to choose the one variable in the one equation that would have had me do no division, right? Just try to keep it as simple as possible. So when you're doing these problems on your own, I actually encourage you to look out for stuff like that. Look at the equations, look at the variables and say, for this first step for substitution, which variable is going to be the simplest to solve for, right? The one that's going to require the least amount of steps. And that's always a great choice to go ahead and pick for your substitution, okay? So, moving on, I have now solved for my y variable. So, now we move into step 2, right? We substitute. So, in order to do that, and I'm actually going to go ahead and let's do this up here. Okay, you know what? I'm gonna rearrange my work just so I can get more board space. I'm gonna move this step 1 up to here, and I'm gonna start step 2 down here. So step 1, we have 2x plus y equals 5. We now have y equals 5 minus 2x. So I solve for y. Okay, so now we can start with our step 2, which is to substitute. I'm going to go and box off this question. Alright, so now we can start with step 2, which is to substitute. So we're going to take this equation, or this variable we just solved for y, and we're going to plug it into our remaining equation. In other words, I'm going to have 3x minus 2 times 5 minus 2x equals 4. Alright, I have substituted the variable y. And again, going back to that discussion we just had, why is this so nice? Why is this technique so powerful? Because now, look at what we have. We've reduced this to a single equation, and there's only one unknown in that equation, the variable x. So all we need to do is solve for that variable x. So that's exactly what step 3 is. Let's solve for that variable. So now we're going to get 3x minus 10, right? So we need to distribute the negative 2 here. Don't forget that minus sign. So we're going to have plus 4x equals 4. Combining like terms, I'm going to get 7x, adding the 10 over equals 14. X equals 2. So there you go. Okay, so there's our step 3. Now step 4, there was that back substitution I talked about before. So if you're still confused on that, no worries, we're about to clear that up right now. We have solved for one of our variables. We have the x value, so we simply need to understand what is the y value because our solutions are still coordinate pairs, they are points. So I take this x, and all you need to do is plug it back into one of your original equations. I guess technically you could also plug it back in here because this already solves directly for y, but I don't know, just to get practice, we can just plug it back into our original equation. So we get 2 times 2 plus y equals 5. You get 4 plus y equals 5. So you get that y equals 1. Okay? There you go. Therefore, the solution to this equation, and our step 5 where we check, so the solution is the point 2, 1. And we don't need to check because at the start of the lecture, we already did list out that point 2, 1 was a solution to both these equations individually. We talked about that at the start of class. But if we hadn't done that at this point, all we would do to check is simply take this point, plug it into each equation separately, see that they both come out to be true statements. And there you go. Very straightforward, not that challenging of a process. The only parts that might be a bit challenging is if we're still not comfortable with substituting. Definitely make sure that we get some practice here, start getting more comfortable with that, because that is the core of this technique. Besides that, it's simply taking these two things that are separate, solving for some variables so that we can combine these equations, create that one equation with the one unknown, solve for that, go back with this information we've gathered to solve for our remaining unknown. This is the entire idea of the method of substitution. So here's our first example. Okay? So go ahead and take a moment now to pause the video, get all this work copied down, and after you unpause, we'll go ahead and move on to the method of elimination and talk about what that outline or that process details. So go ahead and get all this copied down. Okay, so for our next technique, that being the method of elimination, here's going to be the general outline of the technique. The first step is to pick a variable to eliminate. So you're going to have your system of equations, you're going to have whatever variables you're using, x, y, w, z, whatever, it doesn't matter. You're simply going to choose one variable you want to eliminate. Alright, so what do we mean by eliminate? Well, that comes in that idea comes here in the step 2. So what we're going to do is that we are going to multiply or divide. So we eliminate and we're going to multiply or divide to the equations in a manner where the variable we chose from 1, so in a manner where the variable we chose from 1 in both equations differ by a sign, okay? In other words, you're looking for something like this. So if we chose to eliminate x, the x's in the two equations differ only by a sign, all right? So here we choose to eliminate x. And that's why we have now modified or altered our equations in a manner where the variable we chose to eliminate differs by a sign. And then, here in the step 3, we're simply going to add both equations together. Why is that important? Because when we add these two equations together, these x variables will cancel, because ax minus ax is 0. We have eliminated the variable. That's exactly what the step 3 does. It's after you have altered the equations in an appropriate manner, in this step 3, we eliminate. Okay, so there are still a couple more steps. I just don't have the board space. So go and take a moment now, pause the video, get these first 3 steps copied down, and then we'll list the rest of the process. So go ahead and pause now. Okay, so let me go ahead and erase this so we can get through the rest of the steps for this method. So, at this point we've kind of done all the heavy lifting for this method. All the hard parts are pretty much past us, because what should be the scenario after you add these equations? After you add these equations, you've removed one of the variables. So again, just like in that substitution technique, at this point we should be looking at one equation with one unknown. So our step 4 is going to be solve for the remaining variable. And then step 5 is going to, again, just like with that substitution technique, step 5 is going to be back substitute. We're going to back substitute and solve for that remaining variable. And then lastly, the universal step, we got to make sure we check. Okay, so elimination, another technique used to solve system of equations. So why don't we go ahead now, take a moment, pause to get this copy down. After you unpause, we'll go ahead and do an example, and we'll do that same system we did for substitution, but this time we'll solve it with elimination. So let's go ahead and try that now. Okay, so for our first example, using elimination, we'll use the same system we did for our last example, but solve it with a different method this time. So, first step in elimination, pick a variable you want to eliminate. Again, doesn't matter which variable you pick. You can pick x, you can pick y. There is no consequence to picking either. Alright? Just some of them maybe have easier steps to do than others. That's why for me, in my first step, I'm going to pick y. Alright? So why is that the variable I chose? Well, looking in step 2, right? What was step 2? Step 2 said alter your equations through multiplication or division in a way so that both equations, the variables in both equations, differ only by a sign. Okay? In other words, I have y and minus 2y here. So I want these to differ by only a sign. So, in essence, all I need to do is multiply this top equation by 2, right? So multiply top by 2. So I have 2 times 2x plus y equals 5. And oopsies, that's also being multiplied by 2. And I still have 3x minus 2y equals 4. So bringing our work up to here, right? So I multiply the top equation by 2. Why do I do that? Well, after I multiply by 2, I now have 4x plus 2y equals 10, and I have 3x minus 2y equals 4. And would you look at that? The variable we chose y, in each equation the y variable differs only by a sign. You have a positive 2y and you have a negative 2y. Okay? So that's what If you were a bit confused on the wording of that step in our outline of the process, hopefully this example makes it a bit more clear. You just want to be multiplying and dividing by numbers in order to make these variables match up, okay? So, this wasn't the only way I could do it. Yet again, there were several paths I could have taken. Say I still chose to eliminate the y variable. Instead of multiplying this top equation by 2, I could have divided this bottom equation by 2, right? If I divided this bottom equation by 2, I would have had a minus y here, a plus y on top. I would have accomplished the same goal of the y's differing only by a sign. The reason why I didn't choose to go down that path was because we can see right here with a 3x, if I divided by 2, I would have had a fraction. I'd rather avoid fractions if possible. So I said, okay, since I don't want to deal with fractions, it'll be simpler to just multiply by 2. Again, I didn't need to choose y. I could have simply chosen x instead. Still would have been the same process, all right? Still would have simply multiplied or divided the equations in manners where they match, the variable matches up, the variable differs only by a sign. Still, it'll work just fine if I chose the x variable. If I had chosen the x variable, I would probably have done something like multiply the top equation by 3 and multiply the bottom equation by -2, because then I would have a positive 6 and a negative 6x on top and bottom. Differ only by a sign yet again. But I chose to go with y. The reason why I chose to go with y is because I saw it would need the simplest multiplication, and that I would only even need to multiply one of the equations. The other one I could leave alone. But just want to emphasize the facts that, again, it does not matter what variable you choose. It does not matter how you manipulate to have the variables differ only by a sign. All that matters is whatever variable you choose, whatever manipulation you do, it's all correct. It's all using valid operations. That's the key part. But then going back to here, we move on into our step 3. Step 3 says to add the equations. That's an ugly x. So I have 4x plus 3x, 7x, positive 2y plus minus 2y. There's that goal. The y's are eliminated, and I'm left with 14. All right, so step 4, again, solve for your remaining variable, x equals 2. Step 5, back substitutes. So we back substitute into our original equation. 2 times 2 plus y equals 5. Y equals 1. Last step, step 6, we would check, but we've already technically checked with the substitution. We know that's the solution. So our solution is 2, 1. All right. Unsurprisingly, and as should be expected, elimination substitution produced the same answer for the same system. All right. Using 2 different techniques on one system shouldn't produce 2 separate results. You should be getting the same result no matter what method you use if you're doing them on the same system. So here's elimination. Now that we've been introduced to both techniques, in regards to which one is preferable over the other, they're both equally valid. Some of them, when it comes to which one you want to use, I guess, that old question, it just kind of depends on the system and just growing an eye for it. Some systems, in my opinion, are easier to solve with substitution, while other systems are easier to solve with elimination. It's just kind of up to your preference. If you just hate one method, then you never have to use the other method. I mean, unless we ask you like on an exam or homework to use one method in particular. But if the choice is up to you, you never have to use elimination if you don't like it. You never have to use substitution if you don't like it. Again, they both do the same thing. They both accomplish the same goal. It's just that sometimes one is easier to use than the other. And that's kind of something you just kind of grow an eye for. You just use both methods enough, and after a while you start getting a feel for this system looks like it would be easier with substitution or it'd be easier with elimination. But that's just a matter of growing experience. For now, though, let's go ahead and try working on some more complicated examples using these 2 methods now. Okay, for our next example, we're going to go ahead and consider this following system. Minus 2x plus 7y equals minus 15, and 3x minus 5y equals 6. So this one I want you guys to do on your own. Go ahead and pause the video now, and I want you to, I strongly encourage you to actually, please solve this problem using both techniques. Get practice with both. Try solving this with substitution, and then try solving this with elimination. And doing both methods is actually going to be a great way to check your own work personally, because you should be getting the same answer through both methods. All right? So please pause the video now and do this problem using both methods and see that your answers match up in both. If they don't match up, then there is a mistake somewhere in your work. So definitely I'll look through that. But with that out of the way, go ahead and try solving this now. Okay, so hopefully you gave it a shot. Hopefully you tried using both methods to the problem. I'm going to go ahead and just write down the answer I got now. So the answer I got was -3, -3 was the point -3, -3. So hopefully you got the same answer. If not, double check your work. If you managed to get the same answer for both methods and it still wasn't this answer, then that's probably a good indication I did the problem wrong. So send me an email. I can look over your work and maybe I made a mistake. But with that out of the way, let's go ahead and try doing another type of example. Okay, so for our next example, let's consider the following system. X squared plus 4x minus y equals 7. 2x minus y equals -1. So I'm going to solve this using substitution. So I'm going to use substitution to solve this. So, first step in substitution, isolate one of my variables. I'm going to take this second equation and I'm going to isolate y. So I'm going to have 2x minus y equals -1. So I'm going to have that y equals 2x plus 1, right? Add y to this side, add -1 to this side, we isolate y. There you go. So then in my second step, let's go ahead and substitute. So let's box this off. So for step 2, we are now going to substitute. You know what, again, I think I'm just gonna move this over here. 1, so I'm going to have 2x minus y equals -1, so I'm going to have y equals 2x plus 1. Now down here, I'll go ahead and do my substitution. So, substituting in my variable y, I'm going to have x squared plus 4x minus 2x plus 1 equals 7. Okay, now for step 3, let's solve for our remaining variable. We now have one equation with one unknown. Let's solve for that x. So I'm going to have x squared plus 4x minus 2x minus 1 equals 7. Again, never forgetting to distribute that negative throughout. So we have -1, not +1. All right, simplifying down, we get x squared plus 4x, x squared plus 2x minus 1 equals 7. Okay, now looking here, what type of equation is this? That's a quadratic. So why don't we go ahead and move this -7, or move that 7 over. And why do we want to do that? Well, because all the techniques we have for solving quadratics pretty much require that we have the quadratic equal to 0. So then I get x squared plus 2x minus 8 equals 0. Okay, so now from here, since it equals 0, I can go ahead and use my factoring techniques, the quadratic formula, whatever we want, right? So at this point, this should become second nature for us. We've been doing it for pretty much half the class now. So solving this, this one can be easily factored in my head, so I'm going to go ahead and factor it. Comes out to be x minus 4, x plus 4 times x minus 2. There you go. All right, and this still equals 0. So something interesting to note now is, well, I now have factored it. What is this going to do? Well, as with all our quadratics when we solve them, this is going to produce two x's. This is going to be x equals -4 and x equals 2. So I now have two x values. So my next step in substitution was to back substitute, was to take the x I solved for, plug it back in, solve for y. So this time around, since I have two x's, I need to do back substitution twice, and I'm going to produce two y values. So in other words, just looking ahead, I'm going to have two solutions for this system of equations. So yes, it is possible to produce two solutions for a system. Exactly this right here, right? If we ever see an x squared in our system, that means we're dealing with a quadratic. Quadratics have two solutions. We should expect something like that. Well, really tongue twisted myself right there. If we have a quadratic, we should expect to see something along the lines of two solutions. So when we're solving this system, that's not too big of a surprise right there. So we just need to make sure we're clear on the understanding of, in our next step, we need to back substitute twice. Got to produce two y values. So, as you can see though, I've kind of run out of board space. So at this point, go and pause the video. Oh, I guess I should point an arrow to here. Alright, so go and take a moment now, pause the video, get this work copied down. I'm going to start with a fresh board and back substitute and solve for the two y's produced from those two x values. So go ahead and pause now. Okay, so let's go ahead and back substitute. I guess I'll leave the original equation up on the board. No reason to erase that. So then, starting with x equals minus 4, plugging that into my bottom equation, and again, I'm simply going to plug the bottom equation. No real reason why, just that for me, when I plug it into here, it's going to be simpler for me to solve. I could have easily just plugged it into here as well, but that one's just easier. So I'm just going to plug it into here. So you're going to have 2 minus 4, 2 times minus 4 minus y equals minus 1. So you're going to have minus 8 minus y equals minus 1. Alright, adding the y over, adding the negative 1 over, we're going to have y equals minus 8 plus 1, so y equals minus 7. Beautiful. Alright, okay, solving for the other one, x equals 2. Again, plugging this in, 2 times 2 minus y equals minus 1. 4 minus y equals minus 1. Add the y over, add the negative 1 over, y equals 4 plus 1, y equals 5. Okay, checking these answers real quick. I guess I'll do right here, check. Alright, checking these answers. Let's check the negative 4 comma negative 7 pair. So we're going to have negative 4 squared plus 4 times negative 4 minus negative 7. And we're going to have 2 times negative 4 minus negative 7, or minus negative 7. Alright, simplifying this down. That's negative 4 is 16, or negative 4 squared is 16. 4 times negative 4 is minus 16. They're going to have plus 7. That cancels out. We equal 7 just like we wanted to see there. Beautiful. We have minus 8 plus 7. Minus 8 plus 7 is negative 1. Beautiful. That solution checks out. Okay, so I guess I'll put the second check up here. There's check 1. Let's do our second check. Check 2. So again, the point is 2 comma 5. So plugging that in, we get 2 squared plus 4 times 2 minus 5, and we get 2 times 2 minus 5. Alright, that's 4 minus 5, which does equal negative 1. Great. That's going to be 4 plus 8 minus 5. That's going to be 4 plus 8 is 12. 12 minus 5 is 7. Beautiful. So, works out just like we wanted to. These are the correct solutions. I guess I'll write them right down here. So our solutions, we have two solutions. It is the point negative 4 comma negative 7 and the point 2 comma 5. Alright? And there you go. So, it is totally feasible for us to produce two solutions when solving a system of equations. Of course, we would expect something like that when we see this squared term, so we know we're dealing with a quadratic equation for one of our equations. That's not too surprising of a leap to make forward. So here's this system solved using substitution, alright? Now what I want you guys to do is pause the video, solve this same system, now solve it using elimination. Do our second method, so solve this system now again, but use elimination. So go ahead and pause the video and try giving it a shot. We just checked our answer, so we know for a fact this is the final solution. So see if you get the same 2 points when using elimination. So go ahead and try doing that now. Okay, so hopefully you gave it a shot, and please do give it a shot. Get practice with both these Get practice with both these methods. Get comfortable with both. Just so you can start getting a feel for which one you prefer to use given certain types of systems. Okay, so with that out of the way, let's go ahead and move on to our next example. And that one, since I solved this one with substitution, I'll solve that one with elimination, and I'll ask you guys to solve it with substitution. But let's go ahead and try doing our next example now. Okay, so for our next example, we're going to go ahead and consider the following system. Minus 3x plus 6y equals 5, and x minus 2y equals 2. Okay? And as I said, I'm going to solve this, I'm going to solve this with elimination. So use elimination. Okay, so let's go ahead and walk through that. Well, first step in elimination, let's pick a variable to eliminate. So, just looking at these variables, I want to pick one of them to eliminate. So again, I'm going to pick the x variable to eliminate. Why am I going to pick that? Because in order to eliminate the x variable, I only need to alter this one equation, right? I can easily make x into the positive 3x to cancel with that minus 3x. So I only need to do multiplication on this one equation rather than multiplying on both equations. Oh, actually, you know, I take that back. I could have also eliminated just the y with only multiplying to the second equation. Oh, so this one really doesn't matter, but I'm going to eliminate the x variable. So pick x. All right, pick x. So then let's go ahead now and alter the equation appropriately. So I'm going to need to multiply my bottom equation by a positive 3x. I'm going to plus 6y equals 5. Multiply the bottom equation by a positive 3. Okay. So continuing the work over here, I'm going to have minus 3x plus 6y equals 5. Then I'm going to have 3x minus 6y equals 6. Okay. Well, great. Now let's add them together in my third step. So I get 0x plus 0y equals 11. All right, I have some 0 terms I can simplify it down. So I have 0 plus 0 equals 11. So 0 equals 11? That's weird. 0 equals 11. Let's double check our work. Original equation, chose to eliminate x, so I need to multiply by 3. So I have opposite signs of minus 3x and positive 3x. So multiplying by 3, 3 times x is 3x. 3 times minus 2y is minus 6y. 3 times 2 is 6. So that's all right. Adding it up, yep, that's all good. But I have the 0 equals 11. Is that a true statement? Well, no, it's not. So we talked about this before, right? What does it mean when we are solving for an equation and we get a false statement? We've eliminated all variables and we have a false statement. Well, that can only mean for us that we have no solution. No solution. Okay? So yes, it is totally possible when solving a system that no solution exists. And that's not too big of an idea to wrap our heads around, right? If you just think about the graphs to these equations, we have two separate lines. What would it mean graphically for these lines? What would it mean graphically for the system to have no equations? It would simply mean, however you graph these lines on our coordinate plane, the lines simply don't intersect each other, right? They're just not going to intersect anywhere because their intersection is exactly what their solutions are. I guess that's a good note to make right now. For a quick graphical side tangent, the solutions to systems are the intersections of the graphs of these equations. So solutions to systems are the intersections of the graphs of the equations. So all it means for a system have no solution, graphically that just means I guess these ones are two lines, so all that means graphically is that these two lines simply don't intersect. They're going to be probably something like parallel lines. So yeah, don't be surprised if when you're working through a system you get no solution. Definitely double check your work like I did. I went back and I went through all my steps again, making sure I did everything correctly, right? Don't simply work through a system, say, hey, I got no solution at the end, move forward and be like, all right, I'm done. If you get a no solution, that's definitely a place where you need to go back and double check your work and be confident that you really did get a no solution and didn't make a multiplication or an addition error somewhere. Okay, so besides that, I actually want to, again, to encourage you guys, pause the video, try solving this with substitution. Get to the that same result of a no solution, but this time use substitution to reach that. So please take a moment now, pause the video, solve this same system again, but use substitution this time around and still get to that same no solution conclusion. All right, so go ahead and try doing that now. Okay, so hopefully you gave it a shot. Hopefully you still saw that you got a no solution, right? And again, just trying to get like thinking ahead and getting practice of what's the easiest going to be to do. Hopefully when you were solving it, you decided that the easiest step to do was to take the second equation and solve for x, right? That would produce the least amount of work that you can then substitute into the top equation. Again, if you didn't do that, no big deal. As long as all your work is valid, you're good to go. All right. So with that out of the way, with this no solution type example taken care of, let's go ahead and move on to our next type of example. Okay, so for our next example, we're going to consider this following system: minus x minus y equals 5, 4x plus 4y equals minus 20. All right. So I would actually like for you guys to go and pause the video now and solve this system. I don't know. Let's have you guys do elimination. All right. So solve this. Solve using Alright, go ahead and take a moment now, pause the video, solve this using elimination, see what answer you get. After you unpause, I'll try working through this problem using substitution. But for now, pause the video and try working on this, okay? Alright, so hopefully you gave the problem a shot and hopefully you have some conclusion. Alright, we'll talk about that. But first, let me go ahead and solve this using substitution, and we'll see what answer I get and how that compares to what you got. So I'll solve using substitution. So I'll solve this using substitution. All right. So again, first step, take an equation, solve for the variable. So I'll take that top one, minus x minus y equals 5, and I'll solve for the x variable. Why not? So I'm going to get minus x equals 5 plus y. So x equals minus 5 minus y. Beautiful. All right. Second step. Second step. Let's go ahead and substitute. So I'm going to get 4 times minus 5 minus y plus 4y equals 20. Oh, minus 20. Plus 4y equals minus 20. Okay, so then distributing out, I have minus 20 minus 4y plus 4y equals minus 20. Simplify the common terms. Minus 4y and plus 4y, that becomes 0. So I have minus 20 equals minus 20. Again, interesting. I have eliminated all my variables. I no longer have variables to work with. But, however, unlike our previous example, what's different this time around, and hopefully you guys came to the same conclusion, is that this time around, this is a true statement. So, just like before, I have eliminated my variables, but differently this time, I've reached a true statement instead of a false statement. So with the false statement, we said no solution. With the true statement, hopefully you remember, we talked about this before, this means infinitely many solutions. So yes, this system does have infinitely many solutions. Okay, so there it is. Again, hopefully you solved it using elimination and got to a similar result. If you got to something like this and just couldn't remember what this meant, well, here you go. This means infinitely many solutions. We have a true statement with no variables included anymore. Therefore, we have infinitely many solutions. Every single point you could possibly think of that lies on these lines will be solutions to the system. All right, then. So with that out of the way, let's go ahead and move on from here. Okay, so now having gone through those varying types of examples and seeing the different types of solutions they produce, we get to end today's lecture video with this nice statement. Systems of two equations can have no, one, two, or more types number of solutions. All right. So when you're solving a system, don't be surprised if it has one solution. Don't be surprised if there are no solutions. Don't be surprised if there's two solutions. Again, two solutions, you expect to see that when you see a quadratic term. And then don't be surprised if there's infinitely many solutions. All right. So just wanted to point that out as a nice statement we get to make about these systems, having worked through several examples now. Now, lastly, for you guys, again, let's go ahead and give you a nice extra credit opportunity for those of you who managed to make it to the end of this lecture video. So your extra credit opportunity this time around will be the following system: 2x squared minus y equals 1, x plus y equals minus 2. Alright, solve this system for me, email me your work, use either of the techniques, whichever one you prefer to use. So email me work. You can use either system, or either method, my bad. And let's make this due next Monday. Yep, again, so yeah, just email me that work. I don't care what method you use, as long as you use one of them. Email this to me before next Monday. And again, I'll go ahead and make whatever your lowest homework score is. Forget it, let's make it a perfect. Why not? Give you guys a little treat, because we're winding down the last bit of the semester. It's almost over, so I'll just make sure we power our way through the last bit of it. Alright, so besides that, that's it for today's video. Hope everyone's continuing to stay safe, continuing to stay healthy, and I'll talk to you guys later.